This conference will now be recorded.
Okay, so good morning all and welcome back to the session. This is Big Data Masters program. In the previous session, friends, what we have seen, we have gone through with certain stuff like Hadoop commands, Hadoop commands. Then that is nothing but recap to previous session. So Hadoop command, and from the Hadoop command perspective, what we have seen like uh, how to create directories, uh, create files, move files, that is from local to HDFS, local to HDFS, and HDFS to local. Okay, then we have seen like copy files. Then we have seen removing directories, directories. So these particular things, what we have seen from the Hadoop command perspective, like creation of directories, moving files from local to SDFS, and what we have seen over there, like say if we are having a particular application, what exactly is happening in Hadoop world? So we will be having different sources. Different sources are there, and source data source basically, and different source are there. These particular source are generating the data generation is keep on going, and what we are doing over here, we are putting this particular data into the HDFS, that is Hadoop distributed file system. So this is done from this particular step. Like we can have different sources. You can think in this particular way, like we are having say PM reports, we are having CM reports, CM reports, we are having say FM reports, we are having certain log files, and you can say drive test logs. So these particular data sources are nothing but providing raw data, and this particular raw data we are going to put inside the HDFS, and like we are moving this particular data from source to this particular SDFS, data generation, and this particular, or what I can say, like data generation is we keep on going over here, and what we are doing over here, ingestion inside the HDFS. So we are having different sources. We can have different sources. Multiple sources can be possible. And what we are doing, we are like putting this particular data. I'm using this particular word. I'm put. Okay, I'm putting this particular data inside the HDFS. Now you might think, say we are having data and we are moving it inside the HDFS, but like we are moving data from HDFS to local as well. But the main thing is that you just need to pay attention. Like we are having raw data, these particular sources are having raw data, and this particular data is huge in nature. And the machine, like what we are having, say PM data. So PM data, this is nothing but a server. This particular server or machine is not able to handle this particular data. That's why it is given to HDFS, so that further processing and all can happen over here, and we will be able to get the processed outcome. So the movement of data from local to HDFS, that will be more than 90%. Okay, and once the data is processed and we are having result, so it might be possible we need to share the result. So this particular portion will be almost or less than 10%, so that will be very less, because from HDFS you can think in this particular way. HDFS is having the benefit of distributed computing. We will be having multiple machines over here, but these particular sources are working in monolithic way. It might be possible only single machine is there and that machine is working in order to generate the data. that particular data is ingested with the help of certain tools. We will be learning those particular tools as well. Like, it is not possible to directly move data from these particular sources to HDFS. Over here we are moving the data from local to HDFS. That is pretty fine. With the help of single command we are able to move. But this particular task, when we will be having different servers which are generating data and we want to process that particular data with the help of Hadoop, so we are moving data inside the HDFS. That is fine. And once we are having the processed outcome, then we will be having less amount of data, and that less amount of data is moved to the source. It might be local, it might be any third party source, it might be certain servers which are displaying the data in terms of, you can say, reports or dashboard. So local HDFS to local, the data can be shared. And then, like we have seen inside the HDFS, like if we want to copy and move the files, that is pretty possible. I have given the assignment to all of you, like how to copy and move the files between HDFS directories. So that is pretty possible. Like, you just need to use CP and MV command and we will be able to do that operation. Then we have seen like how to delete directories or files inside the SDFS. So RM and RMDIR. RMDIR that we have seen in Linux, that is utilized in order to delete blank directory. And once we are having certain content, then RM command can be utilized in order to delete. So if we want to delete files in directory in a one go, then we can utilize rm-r, that is to delete the directory recursively. So that is fine. So apart from these particular commands, there are certain commands, admin related commands. So admin related commands, what I can say, admin related commands. So what we have seen, in order to check the disk space, df is there. So disk space, so like df command is there, and once we are going to use it with Hadoop, then what we need to do, we just need to we just need to place prefix, that is Hadoop hyphen fs, Hadoop fs hyphen then df. So Hadoop dfs hyphen, that is the prefix in order to use this particular command onto Hadoop, and then you just need to mention the path, like for which you are going to calculate. Let me just copy this particular command and increase the font size a little bit. Okay, and let me paste this particular command over here. Okay, so it is going to provide me the disk space, like SDFS, that is running onto this particular port, having this particular size. It has been used this much of space and available is this much and percentage of use. So over here, if you are able to see this particular space, what we are able to see, that is not in human readable format. So if you want to convert it in human readable format, what we need to do, we just need to put hyphen h as well. Just have a look. So hyphen h. So by putting hyphen h, we are able to see the total disk space which we are having, that is 54.5 GB, and 832 megabytes has been utilized, and it is having this much of available space and this much is the used space. So rest, like space, if you are able to see, over here 54G and available is 42G only. So rest space that has been utilized for OS related applications. Okay, so like what we have installed operating system, that is cloud, that is like CentOS operating system. So that particular OS has been, you can say, occupying certain space over here. So like because of that the remaining or available is 42 only, even though like we have used 832.2 megabytes. That is perfectly fine. So if like we want to see a certain like one command is there, that is file system check, FSEK, and check the disk space and check the disk space in human readable format. Human readable format. So what you just need to do, you just need to put -h in with this. So these are the commands. Okay, what I have mentioned, file system check. So FSCK command is there. FSCK, that is file system check. So say I'm having a particular directory. Let me say Hadoop fs-ls and say user and Cloudera. This is the home directory. And in this particular directory, what we are having certain at this particular path we are having certain directories. Say inside the batch 32, what is available? Batch 32, we are having one file, that is file1.txt, which we have uploaded or which we have put in our previous session. So file1.txt is available. Now, I just want to check the details of this file1.txt. So what we are having, fsck command. So what you just need to do, you just need to, uh, let me mention the file system check, file system check command. So Hadoop fs, so fsck is the command, and in order to run it with Hadoop. So you just need to add prefix -f. So, uh, so it can be utilized Hadoop fs -fsck. Sorry, Hadoop fsck. And what you just need to mention, you just need to mention the file path with for which you are going to check. So Hadoop fsck and the file path and what you want from this particular file. Say onto this particular path, you just need to check, say, the files. We are having certain parameters on files, then say block information, blocks, and say the location. Okay, locations. Okay. So with respect to this particular command, you will be able to check the information of this particular file. What is mentioned over here? Okay. So Hadoop FSCK, then the file path and files, blocks, and location. It's looking fine. Let me press enter. Okay, so this particular command is going to provide you certain information like what is the total file size, okay, number of files, directories onto this particular path. You can give the directory path. So it is going to check, it is going to run the file system check on the provided path. So it is like we have mentioned the file path, that's why it is showing file one only. Then total number of blocks in this particular file, this one minimum replication block, this one, okay, default replication, this one, average block replication, this one, okay. So corrupt block, missing replicas, number of data nodes, number of racks. You probably you are able to recall, we have seen racks and nodes related information, like data nodes, different data nodes are there, and these particular data nodes are placed into the different racks. And over here, like what we are able to see, this particular file is having one block, and that is placed in this particular rack of this particular, or that is placed in this particular rack of this particular data node. So over here we are just going to check the health of this particular file, and that is provide you the information about the health of this particular file. Okay, it might be possible, like if you are mentioning the path of a directory, and it is going to list the information or health status of that particular directory. These are like admin related command in order to see, say, replication factor, or like corrupted block information. Then the racks, how many, on how many racks this file or directory is available. In the normal functionality, in the production environment, we will be having data in terabytes. Then that terabytes of data will be placed onto different nodes, onto the different data racks, and we will be having different replicas over here, over there. So different replication factor, different files, and then different blocks. So this particular command is just going to provide you the information about the health of that particular uh, path that you have mentioned. That's why it is known as file system check. So file system check, that is FSCK command. Now what we have seen, like replication. So is there any way in order to change the replication of a particular file? So let me show you. Over here, friends, to be very frank, like we will not be able to see if we are going to change the replication. The command will run. The command will run, but you will not be able to get the benefit of that particular command. How to change the replication factor? Because what we are having, we are having the single node cluster. Once we will have, say, multi-node cluster, then that particular command will work. uh, we will be able to execute at this moment as well, but we will not be able to get the actual benefit. We will be having single block only, or single information only with respect, or single replicas only. So what we are having a particular command that is, say, Hadoop fs hyphen dfs dot replication, and you just need to put a number. Say I just want to have, say, replication number of this of a particular file, for replicas. I just want to have hyphen put, and then you need to provide the source path, and then target path. Mhm. Target path. This is the command. This is the syntax of the command which is utilized in order to change the replica. So Hadoop FS, that is Hadoop file system. DFS, this is like going to add certain admin properties. Hyphen D, like, say, uh, it is going to change the replicas, and how many replicas you want, like 4 replicas, for which file which you want to put from this particular source to this particular target. So provide you let me walk you through with the practical. So what I can have, say, mkdir Hadoop fs hyphen mkdir. I'm going to create a directory, and user Cloudera, this is the home directory, and I'm going to create, say, Saturday. Okay, or data analytics. Okay, so data analytics directory I have created. and what I'm having certain data, say, that is placed onto this share folder. In this particular share folder, this is the directory which I have placed, okay, which I have mapped from the windows. So over here what we are able to see, say, search data, user records. This is a file, and let me check the path of this particular file. So this is placed over here, okay, and this is the path. This is the source path basically, and the user records.txt. This is the file. What I want, I just want to have 4 replicas of this particular file. Input. Okay. So Hadoop FS DFS replication 4 hyphen put, and this is the source path. And where I want to put, I just want to put it inside the user Cloudera data analytics. Onto this particular path, I just want to put this particular file with 4 replicas. Okay. So this is the command. Let me copy this particular command and paste it over here. Okay. So what it will do, it is going to put this particular file with 4 replicas. Put this particular file which is placed onto the local inside this particular data analytics. Now let me check what is the content of user Cloudera data analytics. Hadoop fs -ls, and then this is the path. Let me copy path and paste it over here. Okay. So what we are able to see, we are having user records Cloudera, user records.txt. It has been moved from my local file system, my local machine, that is on like that is the Cloudera local. Okay, one file is there, the user records, and it has been moved inside the HDFS. Now, now we are having the single file only. But and the command has been executed. It has not thrown any error. It has not thrown any error, and it has been executed successfully. And the data I'm able to see. But as we are running with single node cluster, as we are running, I'm repeating it once again. As we are running on the single node cluster, because of that particular reason, we are not able to take the benefit of this DFS replication command. If like we are having multi-node cluster, then we will be having multiple blocks of this particular file, and where we will be able to see inside the Hadoop SDFS node, we are having a file system. We just need to browse the file system. Over here, user Cloudera, where we put the file, and data analytics. This is the directory. And then user records.txt. You just need to click on user records.txt. Yeah. Okay, this is the file. If we are running with multiple nodes, then we will be having the information like block 0 is available, that is the block pool location and all, each and everything will be available with respect to that particular file. Over here, like block 0 onto this particular data node, block 2, block 3, block 4. Okay, in that particular way we will be able to get the information about that particular data, where we have changed the replication factor. Single node cluster, we will not be having the replicas. We will not be having replicas. And like if we are going to create replicas into the different directories and all, okay, that will not make any sense. It is going to increase the space or storage of this particular machines, and the machine will be too bulky and it will not be able to operate. So what we have seen, let me repeat it once again. In order to change the replication factor of a particular file, You just need to utilize DFS replication. You just need to put a number, like this much number you want to have as a replication or as a copy, and then you need to put that particular file into the HDFS. Okay, this is the source path where the file is available, and you are moving that particular file into the target path. And it's going to create multiple replicas based upon the number that you have given. But as we are having single node cluster, so we are not able to get the benefit of this particular command. Okay, and if we are having multi-node cluster, at that moment we will be able to see the replicas information inside the the Hadoop name node, where you will be able to browse the file system, and then you need to click the file will be having the information about the each and every block. Okay, fine so far, huh?
Ashok, one thing.
Mhm.
If we are creating the replicas, so if there are multiple nodes, so file will automatically be decide on which node it is going to create the replicas.
It is decided by Hadoop, and
Okay,
what you are able to see, I'm checking it through the name node. Name node is what? The master of this
master
cluster.
node. Hmm.
Yes, and master node is having the information of what? About the data on which node it is moving. We have seen, like,
Right.
master node is going to
Hmm.
maintain the metadata, right?
Mhm. Right.
Whatever we have studied through the slides and through the notepads, that we are able to see over here,
Clear.
right? It is able to get the details about the files or blocks, and we will be having that particular information over here, right?
Ashok,
Mm-hmm.
if we want to create a replica, so why are we are not using CP command to copy the file? Why the different command for creating the replica? What is
Actually,
difference between copy file to creating replica?
okay, so CP command is going to create the files within that particular node. CP command is going to create. So
Okay,
say, like, I'm going to I'm running onto this particular machine, and I'm going to say create the copy. I'm going to create the copy. So like that particular copy one, and I will be able to create one copy only. I will be able to create one copy only. Now the replication, what we, and like, we will not be having the fault tolerant related mechanism over there, fault tolerance, say, we have seen the rack mechanism. Inside the rack mechanism, it is decided, like, in order to have the fault tolerance, so data or blocks are moved in such a way that if a data node is down, then we will be able to recover it from the another node. Just a minute, let me show you through a particular diagram, then you will be able to get the details. Okay, not here. Hmm. Okay, probably you are able to recall this particular diagram. Okay, over
yes,
here,
Ashok. Yes.
we have created multiple copies. Okay, over here we are having three replicas of each and every block. But if we are having all the replicas in one block and the machine or that particular node is down, then we will not be able to get the we will not be able to recover the data, right? So once you are going to copy, then you will not be having the mechanism, like say fault tolerance related stuff, but once you are going to create the replicas inside the Hadoop ecosystem, then it is the responsibility of Hadoop in order to and the Hadoop is going to align the replicas in such a way that the system will be fault tolerant. Replicas will be maintained in this particular way, right? Right. So if this particular node is down, you will be able to recover this information from the another nodes, right? And like copy inside the for the copy, you just need to provide the absolute path, over once you are going to create the replicas of a file, you just need to provide the destination of over here what we are doing, over here with what we are doing, we are just mentioning the path, like I just want to put this particular file from this particular path to this particular path. This will be the main path where from where I'm going to access, but but apart from this, it is decided by Hadoop itself, like where it is going to store the replicas of this particular file, right? We are not mentioning that
Mm,
particular path, right?
Ashok, Ashok, this
Mm-hmm.
target path, if currently we have only one node cluster. If
Mm-hmm.
we have more than one node, then what will be the
Mm-hmm.
target path? Like how it will be decided
Target
that,
path, target path that will remain same. That will remain same because like you just want to, uh, you are having a particular folder structure, right? A folder structure is there. What you are saying, say, I'm getting the data from this particular source and inside the SDFS, I have created a folder like PM. So PM data will be moved inside the PM directory. CM data will be moved to CM directory. So folder structure, file naming convention, each and everything maintained over here. Okay. But the replicas related stuff that will be maintained by Hadoop. Are you getting?
no, but then what is the difference between this source path and target path?
Source path is like you are moving it from local, like you are say this is the PM data that you are trying to move to HDFS.
Okay, from share folder means
Yes, yes,
it
yes.
is okay, okay, okay,
This is the monolithic machine. This is the
okay,
monolithic path, and over here you will be having the benefit of distributed computing.
okay, understand.
Fine so far, each and every one.
Yes, yes. Yeah.
Okay, so CP and MV, that is like we can do, but mostly like we are moving with uh, CP command, CP not CP but put and get, inside the, because like it is not necessary to create copies once we are having replication. Another thing, another stuff, like I don't know like who have asked, that I'm not able to get the name. So one thing is happening, what I am saying, say replication factor or default replication factor, default replication factor equal to 3 in Hadoop. So if we are moving a particular file, by default it is going to create 3 replicas. By default it is going to create 3 replicas in order to have the fault tolerance. Now you are having a file that is inside the SDFS, say user text, say user records .txt. This file is there. This file is there in HDFS. This file, you need to pay attention. File is there in HDFS. Okay. User record.txt. Now, if this particular file is there, what I am having default replication factor 3. So this particular file already have 3 replicas, and if I'm going to create a copy, okay, so it will have 3 more replicas. This is the methodology inside the Hadoop. If I'm having a file that is having 3 replicas, and if I'm going to create a copy, then it will create 3 more replicas. So user record, let me try to think, mention. So what you are
Ashok,
having?
right now it will not create any replicas, na, as we have only one node cluster.
Yes, yes, it is not creating any replicas. We are
Yeah.
having replication factor 1 as well, which we have seen in properties.
Yes, yes, because right now only one node we are using.
Yes, yes.
Okay.
So we are having one file over here, and we want to copy this particular file. One file is available over here, and one will be available over here after copy. So Hadoop has 3 replicas for this particular file over here, and once we are going to move or copy this particular file over here, then we will be having 3 more replicas. Okay, so it is going to, this particular copy mechanism is going to increase the disk space inside the cluster. And once we are having 3 replicas of a particular file, then what is the need to have 3 more replicas? Either we can go with mv command, that is cut and paste. mv command, it will move this particular file from here, and it will copy it this from here. So we will be having only 3 replicas, right? Fine so far?
One thing, Ashok, one
Yes,
thing,
yes.
if we are doing any modification in this user record data file, so that changes will reflect in replicas or not?
Yeah, definitely it will be there. It will be updated automatically. It will take some time, that
Hmm.
we will see like how the updation and all that will come into the picture. So those particular things are there, the data will be updated.
Okay, fine.
Okay, so we will be having certain issues with respect to that. Like what we are having, we are having certain blocks. I'm not going to move inside the detail at this point of time. I'm just giving you one overview. Okay,
Uh,
like small hint. Yes,
uh,
yes, please.
so, okay. So in the last like command you told, like we create using the command we create 4 replicas. Okay, in
Mm-hmm.
different nodes. If we are
Mm-hmm.
moving these, like by default replica is threes, and according to this command, if we are moving the data from to like in different node, like then we can create multiple like 3 replica in different machine via using this command as well, or we can on a single machine. I'm
Uh,
confused. Uh-huh.
so the thing is that uh,
Mm-hmm.
you are trying from the user perspective. Don't try to think from the single user perspective. What you are having, you are the user of a, you are user of cluster. Say this is a client, and
Mm-hmm.
client is having the access of name node. Name node, it is not like accessing data node directly. Okay, data node directly. So it is going to connect with name node by over here. What it will say, hey name node, I just want to get this particular data. I just want to have say file1.txt. So the name node check the data metadata, and from this particular metadata, it is it get the information like file1.txt is available over here. This is the shortest path. It might be possible like that particular file is available in this particular node as well and this particular node as well. Like we are running with three replicas, three default replicas, say. So the file1.txt is available over here, and over here. Okay. So the file1.txt is available in three nodes. So name node is going to connect with say data node this one, and it is going to provide the details of this the location that file1.txt is available in data node 1, and then data node 1 the client will interact with data node. It is not directly interacting with data node. Okay, it is interacting via name node. So once like it is done its operation, it is saying say like name node I have done the operation, and it is able to see like say certain updation in the record. So it will come, then this particular name node is going to align the same stuff inside the replicas which are maintained. Okay, now say this particular client want to create the copy. So copy where he's not having the information about data node 2 3 4. He's just having the access to this file1.txt. What it can what this particular client can do, it can like copy it towards the local side. It is running on local. It is not using it is not having the access of data node 1 data node 2. Okay, data node 2, it is having its own IP. It is have these particular machines, these particular machines are having their own IPs, say uh, location basically, node location. So these particular machines are connected through internet. Now if this particular client want to create the copy, okay, want to create the copy, so what will happen, like say file1.txt is available, and say file2 it has created a copy, and the name will be say file2.txt. So file2.txt is available, and it will be decided by the name node like where it is going to store. Say it might be possible over here and over here. Okay, so we are not going to decide like I just want to store the file copy or replicas in data node 2 data node 3 4. It is decided by the name node, right?
Okay,
Name node.
okay, got it, got it, got it.
Okay, so you are the user of the cluster, you are not the cluster. You are accessing the cluster. You are
Mm,
thinking that I'm sitting in data node 1, what I'm observing at this moment, and I want to copy this file from this machine to this machine. I will not be able to do that. You are not the cluster. You are the user of cluster.
We are not Hadoop.
Yes, you are not Hadoop.
mm. Okay.
Okay, so that is there, and we have seen like how to create the replicas and all. That is perfectly fine. Now, if we talk from the Hadoop perspective, what we are having three main components. Let me show you. We are having three main components. Hadoop is there, what you are able to see over here. So Hadoop is there. Then HDFS, we have seen HDFS in detail. And that is nothing but a storage layer. We are just moving the data, and it will be maintained in terms of blocks. Then another component inside the Hadoop, what we are having, that is MapReduce. That is the processing layer. And third component in Hadoop, what we are having, that is Hadoop. Yarn. That is nothing but the cluster manager. So what I'm going to explain Hadoop components. So what we have seen, Hadoop is there and it is having say HDFS, then MapReduce, and then Yarn. Okay, Yarn. This we have seen. Okay, so Hadoop is having three components: HDFS, MapReduce, and Yarn. HDFS, that is nothing but storage layer. MapReduce is nothing but the processing layer, and this is nothing but cluster manager. Okay, yet another resource navigator. That is the cluster manager. It is going to like manage all the resources inside the cluster. So storage layer we have seen if we are having certain applications which are generating the data or certain servers which are generating the data, what we are going to do, we are just putting the data inside HDFS. Over here as well we are able to see like these particular applications were there and these are ingesting the data inside the HDFS. However, what we have seen, we have just put the data with the help of put command so far. And the data is there inside the HDFS, and then uh, like we are able to maintain huge amount of data perfectly fine. This is storage layer and data is maintained in terms of blocks. And Hadoop 1 is having a default block size 64 MB, and Hadoop 2, that is Yarn basically, is having the block size 128. So we are having data inside HDFS. Now, until unless we are not processing data, then that is not making any sense. So we are having the processing framework inside the Hadoop that is known as MapReduce. And Yarn, that is going to maintain the resources of the cluster, resource manager basically. Okay. So if a particular job flow, let me mention the job flow. So execution flow. Flow in Hadoop. Okay, so job flow. So inside the job flow, what we are having, we are say we are getting a file. Uh, file. The file is given to the splitter, and splitter is the file is there. What I can say a 550 MB file. 550 MB file was there and name as a file1.txt. That is the name what we are using. Okay, so this particular file is given to the splitter, and splitter is going to do what? It is going to split it. So 550 divided by 128, how many blocks are there? 550 divided by 128. Hmm?
5.
Okay, so 5 blocks are there. Or let me be a little bit more specific. 512, and you will be having 4 blocks. Right? 4 blocks.
Yes.
So
Yes.
it has done the splitting, and we are having 4 blocks. Now these particular blocks are given to a particular person named as record reader. Record reader. Okay. Record reader and record reader to mapper, and from mapper to reducer. Okay. Now what we are able to see over here, we are having two main components, record reader, and three main components: record reader, mapper, and reducer. Okay, we are able to see the functionality of splitter, and the functionality is very simple. It is going to split the data whatever it is getting in terms of in the multiples of 128 MB. So blocks are there. Now record reader, what is the need of record reader? So record reader, before moving with record reader, I'm just going to explain this MapReduce. What I have mentioned, like MapReduce, that is the combination of two words, map plus reduce, mapper plus reducer. So mapper plus reducer, what this mapper is doing, mapper is going to distribute the task. It is going to distribute the task, the task among different machines, different available machines or nodes, machines, public nodes, uh, in order to process it and provide intermediate output. Then reducer, what the reducer is going to do, reducer, this reducer is going to take the intermediate output, take the intermediate output from mappers and provide final output. Okay, so we are able to see the functionality of mapper and reducers, mapper and reducer as well. Mapper, that is going to divide the task among the available machines. Say if we are having 4 machine, 5 machine, or 10 machine, so these particular blocks are given to those particular machines, available machines or nodes. Those particular machines will work on to top of that particular data and then provide intermediate output. Let me mention over here output, and this intermediate output is given to a reducer, and reducer is going to do what? It is going to reduce it, intermediate output, and then reducer is going to provide the final output. Final output. Okay, that is perfectly fine. So we are able to get the functionality of splitter, mapper, and reducer. But why we are having record reader at this place? So friends, there is one important thing that we need to understand. This mapper is able to understand the values in this is able to understand well the data in key and value pair. So it is accepting the data in key and value and providing the output in key and value pair. Mapper input, accept input, input in key and value pair, and provide output in key and value pair. Okay, so that will look like this. You are having a mapper is going to provide key and value, key comma value, and mapper what it will take, it will take key and value. Okay, that is say input, and this is the intermediate output. Okay, so what I mentioned, this particular person named as mapper that is able to understand the input in key and value pair, and it is going to provide the output in key and value pair. Because of this particular reason, we are having record reader. Okay, record reader is going to do what? Say it is going to add a random number with the record reader, with that particular block, and it is going to convert the data in key and value pair. You can think in this particular way. I'm having this particular pipeline. Okay, I'm having this particular pipeline, and let me paste it over here as well once again. Now say we are having block 1. I can walk you through with a particular data. Say I'm having data. Say, hello, uh, how are you? Okay, welcome to Booster Analytics. Big data is going to change the world. Big data is big. Okay, so we are having, this is the content what we are having in file1.txt. This is the content. Okay, and what we have done on to top of this, we have created blocks. Say block 1, block 1, and in the same fashion what we are having block 2 and block 3 and block 4. We are having this particular block information, block 2, block 3, block 4. So file1.txt was there, and what it is given to say splitter, and splitter say output from splitter, what I can say, output from splitter, what it will be, it will look like this. This is the output from splitter. So it has converted this particular data in terms of blocks, and we are having 4 blocks. But we can't give this particular data to mapper, because what we are having a limitation, this particular mapper is able to understand the data in key and value pair. So what this particular record reader is going to do, it is going to take the block, okay, and add a random number. Output from say output from record reader. So output from record reader, what it will be, it will look like this. It is going to take the data, okay, and it is going to add a random number. Say let me add a random number. So this is the say random number, and this is the data. Okay, in the same fashion like what we are having with this, it has added a random number. These are the random numbers. I'm just typing randomly. Okay, in the same fashion like it will be having certain random numbers. Okay, and then big data is big. So what we are able to see over here, the record reader, what it has done, it has added a random number with each and every block. Now you might think, you just need to like think over here, this is nothing but a key and value pair. This is nothing but key and value pair. This can be taken as a key, and this is the value, this is a key, this is a value. Now the data is there in key and value pair. Now we will be able to feed it to mapper. we will be able to feed it to mapper, because the mapper is able to accept the data in key and value pair. So the random number has been added with each and every block of data, and it is given to the mapper. Now mapper will be able to work on to this particular data. That is perfectly fine. Huh? Now the output from mapper, what I have mentioned the output from the mapper is in key and value pair. So this particular component, reducer, that is also taking the input in key and value pair and providing the output in key and value pair, reducer, and that will be the final output. Okay, that is also providing the output in key and value pair. So reducer is also taking input in key and value pair and providing output in key and value pair. So at this moment, what we are able to see, mapper is providing key and value pair, so that can be given directly to the reducer, and reducer will provide you the final output on top of this particular data. Now in order to like go in detail, we will be moving with the word count program. Word frequency calculator. Okay, so I will walk you through with the logic what exactly will happen. So say I'm having this particular data. So I'm having and let me mention in this particular way. I'm having 4 node cluster. I'm having 4 mapper machines, in another word. Say mapper 1, mapper 1, mapper 2, and mapper 3, and mapper 4. Okay, I'm having 4 mappers in my machine, in my cluster. This is say the cluster what I'm having. Uh, uh,
Mapper count will be same as the count of the nodes, no?
no, it is not exactly the same, but in order to give you the better understanding, mapper, like it is not like say one machine. One mapper is like one block is given to one mapper, right?
Mm, okay, means the number of block will be same as the number of mapper, no? Means if we have 10 number of blocks, then we will have 10 mappers.
You can think in this particular way, like blocks can be anything. Okay, and I'm having a particular job. I'm having a cluster. Okay, and I'm going to provide certain resources from that particular cluster. That will be nothing but some containers. Those containers are nothing but the mappers, right? One mapper can handle multiple blocks. Are you able to get?
Okay, okay.
Okay, container is nothing, one mapper. In one container we can have multiple blocks, but at this moment, in order to get the understanding about the mapper concept and all, try to think in this particular, like one machine is say one mapper, okay, that is nothing but a container, right? Big container. Fine.
Yeah.
Okay, so what we are going to do, we are going to calculate the frequency of each and every word. Uh, say what will be like big is there, say big is there, like let me mention big. So big is there, say big 1, 2, 3. So what I can say, the frequency of big is 3. Data 1, 2. So frequency of data is 2. Welcome is like coming one time, so the frequency of welcome is 1. Age is there 2 times, so the frequency of age is 2. So in this particular way, in order to understand, in order to deep dive in the functionality of this particular MapReduce, we are going to move with the word count program. So if I'm having this particular block, and if this particular block is given, and I just need to calculate the frequency of each and every word, then what I need to do, first of all, I just need to split this particular word, the line into words. First I'm going to split this particular line, and then what I'm going to do, I'm going to do the calculation locally. Say mapper will one will work on to the data which is available over here. Mapper 2 is working onto the data which is available onto mapper onto mapper 2. Mapper 3 is working with respect to the data which is available over here, and mapper 4 will be working onto the data. Now we are moving with word frequency calculator. So first of all, like the splitting will happen, and and then splitting, after splitting, I'm going to assign one with each and every word. I'm going to assign one with each and every word. Okay. So if I'm going to assign one, and then it will be look like this. Just have a look. So this is input to the mapper. Input to the mapper, input to mapper, that is this one. And what will be the output from mapper? Output from mapper. So what I mentioned, the mapper, what this particular mapper is going to do, it is going to avoid this particular key, that is nothing but the random value. There is no need to have there is no usage of random value, so it is going to avoid this particular key, and it is going to work onto the value. Okay, so what it is going to do, it is going to work in this particular way. So first of all, it is going to split each and every word. Okay, splitting is done, that is perfectly fine. Now it is going to assign one with each and every word. Hello one, hello one, then say how one, r1, okay, and u1, u comma 1. Okay, what it has done, it has splitted the data, it has splitted the line what it was getting, and then it has assigned one with each and every word. In the same fashion, like this will be the functionality. Say this is mapper 1, output mapper 1, then we will be having mapper 2. Mapper 2, what the mapper 2 is giving me, let me mention this particular mapper 1, it has given this one. Mapper 2, it has given this one. Say it is going to first split the each and every word, split the lines into word, and fix one with each and every word. Boost analytics, perfectly fine. This is done by mapper 2. In the same fashion, the mapper uh, 3 will work, and what I will be getting, the words by fixing one with each and every word. I'm just writing the logic, like how the frequency calculator will work. Okay. Okay. So this is the mapper 3 output, and in the same fashion, the mapper 4 will work on the top of this particular data, and it will provide the outcome in this particular way. Okay. One data of one, data one is one, and say big one. Okay. So what we are able to get the output, say hello one, how one, r1. This is nothing but the output from the mapper 1, 2, 3, 4. Each and every mapper has worked on to the incoming data. This is the input to the mappers, and these particular mappers has worked in such a way, and we just need to write this particular logic. From the developer's perspective, if you are working onto like the Hadoop related stuff, in order to have the optimization or processing of your data, you need to write down the logic. Okay, like why the splitting is happening over here. This is based upon the logic, because in order to calculate the frequency of each and every word, we need to split the lines into words. And then once we are having splitting of each and every word, we are just going to fix one with each and every word, and then what we are going to perform, we are going to club each and every, you can say, word, or we are going to short this particular data first, and after shorting, like say we will be having big one at one location, data big on at one location, data at one location, and then we will be going to keep the key and then work on to the values. This is nothing but key and value pair. Hello one, this will act as a key and value pair. R1, how one, that is nothing but key and value pair. If the data is there in key and value pair, that means this reducer can work. What we have seen, the mappers has taken the input in terms of key and value pair, and onto this particular data, it has worked onto the logic, based upon the logic what we have written, and we are able to get the words by fixing one with each and every word. So we are able to get this particular data, and this particular data, what we can do, we can feed it to the reducer, and reducer, what the reducer will do, so before moving to the reducer, what will happen, the shorting and shuffling will happen. Shorting and shuffling. Shuffling, shorting and shuffling. So shorting and shuffling, that is nothing but movement of the records from mapper machine to reducer machine. So what is happening over here, shorting and shuffling. Shuffling, say we are having certain data over here, we are having certain data over here, on each and every node we are having some data. Now we need to move this particular data onto the reducer machine, and that operation is called shuffling. And friends, this is the costly operation. If we are talking about big data operations, shuffling is an operation which is having highest latency. So we need to think in this particular way. In order to do the optimization onto this particular pipeline, we just need to work on to minimization of shuffling. The shuffling must be done with less amount of data, or onto some operations we are going to avoid shuffling, where we want to have the performant job, we want to minimize the amount of shuffling. Why shuffling? Because over here data will through will be like moved among different nodes. One node is there, it is going to move the data into different node. Once the movement is there, then definitely that will take time, and that will be having latency issues, latency crunch. Another stuff, the very important thing, this reducer is what I can say the poor person. This is the poor person and this is the richest person. These are the richest person. Why? What we are having over here? Over here we are having the benefit of distributed computing. Distributed computing or parallelism is there. Parallelism. What it means? It means like on a particular data, we are having multiple machines. The data is parallelly executed. Say, hello, how are you is given to this mapper 1. Mapper 1 is working on to this particular portion. Mapper 2 is working on this portion. Mapper 4 is working on this portion. So what we are having parallel execution is keep on going over here. But once the shuffling is done, each and every node is going to provide their data to the reducer machine, and this particular person, what I used to say the poor person, is going to work on to all the data which is given by these particular mappers, and then it is going to provide the final output. Now you can think in this particular way, we are having multiple machines over here which are working on a data, and over here say we are having single machine which is working on to a particular data. So what we need to do as a developer, we just need to try to perform maximum operations over here only. Just focus onto the cursor, I'm hovering onto the mappers. So being a developer, you just need to write down the logic in such a way that maximum processing will be done over here only. You are going to, like, we can't avoid to provide data, because like we need to have the final output. We just need to take the give it to reducer that will provide us the final output. So we need to think in this particular way that the data which is given to reducer, that must be very less, okay, because it is going to provide the final output. Now the shuffling and sorting will happen. So shuffling, that is nothing but movement of records from one machine to another. Shuffling, that is movement of records from one machine to another machine. And for specific over here, like mappers to reducer. From mappers to reducer. Perfectly fine. So over here shuffling and sorting will happen, and once the shuffling and sorting is done, just what we are having, what we will be having, say R is there. It is going to sort the data. R is there. Then R, nothing is there, started with A. Then B, big is there. It is going to take big and big. Big 1, big 2, and say big 3. Three bigs are there. Booster analytics is also there. Okay, booster analytics. Okay, then change is there. That is going to short alphabetically. Then probably data is there. Data one. Okay, and hello is there. Hello. Then say welcome is there. Welcome, and then you is there. 2 is there.
Ashok, this shuffling, I'm still not able to get.
Hmm. Not an issue. Not an issue. I will explain once again. to welcome world is going. I'm going to short it. Okay, how? Okay. So, shuffling is nothing but movement of records. Uh, you know what we are having? We are having multiple machines. Mapper 1, 2, 3, and 4. Okay. So these particular machines are working. Now, what we will be having, each and every machine is going to provide intermediate output. Say IND, let me mention in this particular IP1, intermediate output, IP1, then intermediate output 2, IP2, IP2, then IP3, IP3, IP4, intermediate, that is intermediate output, IP4, okay, or IO, intermediate output, IO, intermediate output, IO, IO. So this is the intermediate output. Is this like what I need to do in this with respect to this particular output? These particular intermediate outputs, I need to give these particular intermediate output to a person who can club these intermediate output and provide me the final output, right? Because my motto is to get the final output. Is this the final output what I'm able to see? This is the output from mapper. This is the output from sorry, this is the output from mapper. This is the output from mapper. Is this the final output? Yes or no? Is this the final output?
No.
That is not a final output. Perfect. So now this is not the final output. This is available at machine 1. What I need to do, I need to move this particular data to another machine, or all of these particular machines are going to move this particular data to another machine, that is nothing but reducer. So movement of data will happen, movement of records will happen, and this movement of records from one machine to another machine or mapper to reducer, that is known as shuffling. That is known as shuffling. Now this particular shuffling, why I used to say that is the costly operation, because that is time taking process. Like multiple persons are going to provide the data to single machine, and it is going to handle the data, and this particular movement will happen over the network. Okay, over the network via switches, this particular movement will happen. If you are able to recall the rack mechanism, like from one machine to another machine, the movement of record will happen, and it will happen through switches, and switches are going to add certain latency, right? So movement of data from one machine to another machine, that is nothing but shuffling. Is it clear?
Yes, Ashok.
Yes, yes.
Okay. So movement of record is nothing but shuffling, and once the shuffling is clubbed with shorting as well. So what we will be having, we will be having the data shorted in this particular way. So what we are having are one big one. So the data has been shorted. Now this particular data is given to reducer, and reducer is working in such a way, like we are going to write down the logic for reducer. So if I'm a reducer, if I need to do the word count program, then I'm going to do, I'm going to keep the key and work on to the values. Just focus over here, keep the keys and work on to the values with respect to our frequency calculator. So what will be, this is input to the input to reducer, input to reducer. Then output from the reducer, what it will be? Output from reducer. Output from reducer, what it will do? It is going to, let me copy it first. Okay. And it is going to work in such a way, it is going to keep the key and work on values. So it is going to keep the key and say values. So what we are having, big one, so we are having three bigs, so it is going to keep the keys and work on values, values. So these big are removed. Then boost analytics, nothing is there. So then change, there is no repetition. With respect to data, what we are having two keys, so it is going to do in this particular way. Okay, one key, one data will be deleted, going, that is perfectly fine. Okay, and hello, that is also fine. How, that is fine. We are having two is, I think so, is are there, two is are there, so let me mention onto the top as well. Okay, so it is going to keep the keys and work on to the value. Perfect. Then they do single time, no repetition of keys, welcome, single time, no repetition of keys, world, single time, no repetition of keys, you, single time, no repetition of keys. Okay. So what will happen? It is going
Is one
to,
correct? Is plus 1 plus 1.
oh, that is fine. Okay, thanks. So what we are having, it is going to keep the keys and work on to the values. And this particular stuff, like either like we are going to plus or performing addition or multiplication or division, being a developer, we just need to decide this particular logic. We are going to calculate the frequency of each and every word. So based upon our logic, like what we will be having, we need to perform the sum of the values. So we will be getting this particular output. Okay, so and this is nothing but the frequency of our words what we have given in file1.txt. So this particular reducer is going to provide the final output, and what we are able to see, this is nothing but the final output, and this is what we have decided now, word frequency calculator, right? Word frequency calculator. So we will be going to we will be going through with the Java code, that is sample code. Basically there is no need to go inside detail about that particular code, but in order to provide you the insight like how the calculation is being happening in different parts of like this particular job flow, so we will be going through with that particular program. So this will be the final output, and how the reducer is working, it is going to keep the keys and work onto the values. And who is going to decide this? We as a developer are going to decide, like you just need to keep the keys and work onto this particular logic, apply this particular logic onto the values. Over here at the mapper side, what we have mentioned, like we have mentioned that you need to split the lines so that it will become word, and assign one with each and every word, so that further it will be given to reducer, and reducer will work in this particular way. So we are going to decide the logic of mapper and reducer. The code for mapper and reducer is decided by the developers. Now let me copy this once again and let me paste it over here. Okay, and let me minimize the size a little bit. Okay, so file1.txt then given to splitter, mapper and all, that is fine. Intermediate output, that is also fine. Okay. Now what we are having, what I mentioned, reducer are going to provide me the final output. Reducer provide me the final output. So and what I have mentioned that we just need to like work in such a way that a reducer will be having less amount of work that will be performed. Okay, but it might be possible the data which is given by this particular mapper, the single reducer is not capable to handle that particular data. The single reducer, try to pay attention over here, single reducer is not able to handle the data. So at that moment, what we need to have, we need to have multiple reducer. Let me copy and paste over here. Reducer 2, reducer 1 and reducer 2. So reducer 1 and reducer 2, we are having two reducers because the single reducer was not able to handle the entire data which is given by these mapper machines. Okay, now we are having two reducer, but who is going to decide which data is given to which reducer? Like mapper 1 is like providing the data, mapper 2 is also providing, mapper 3, 4, 5, say we are having thousands of mappers and those particular mappers are providing the data to reducer, but which mapper is going to provide the data to which reducer? Who is going to decide that? Okay, so that is decided by a person named as partitioner. Partitioner. Okay, partitioner is the person who is going to decide like the data, which mapper, let me mention over here, partitioner. Partitioner, it is going to decide, it is going to decide which mapper is going to provide which it is going to decide which mapper provide the data, provides the data to which reducer, okay. So it is like decided by or in another words like
Ashok, if we are using only one reducer, then I think there is no need of this partitioner, na?
yes, there is no need of partitioner at that moment. So
Okay.
partitioner is going to decide which mapper, not which mapper, but I can say which key is given to which reducer. Is given to which reducer. Okay, over here, just like we will be having this particular data. This is input. This is the data which is coming from the mapper. This is coming from mapper. Now over here we will be having multiple keys. Now this particular person, partitioner is going to apply a logic. Okay, this is going to apply a logic like which key is given to which reducer. Okay, so in this particular way, or mhm, in this particular way, which key is given to which reducer. So like it is working on to the certain logics. Certain logics, certain hash functions are working over here inside the partitioner. Even like you can write your logic that I just want to move the keys which are having say length. Let me mention, say word length less than say 4 to reducer 1, and word length greater than equal to 4 and reducer 2. Okay, so we can write specific logics as well. If you are not deciding, if you are not mentioning a logic, then partition and you have mentioned that you want to have two reducer, we will be going through with practical that I want to have two reducer. Okay, I want to have 4 mapper, 5 mapper. We will be going through with practical. So what will happen, it is going to decide that which key is moving to which reducer. If you are not mentioning, like it will move with the it will move with certain system defined logic. Okay, simple one is the hash logic. Let me provide you some insight. I'm just giving you overview. So like say mapper 1, and say it will be working in this particular way, like say percentage division 1, and then modulus division, say I'm having two reducer. So two modulus division 1 modulus division 2, so it will be 1, so it will be given to reducer 1, it will be given to reducer 1. Then in the same fashion, like say we are having mapper 2 and 2 modulus division 2 remainder will be 0, so it will be given to uh, 0, and it will be given to the reducer 0. Then if we are having reducer mapper 3 modulus division 2 remainder will be 1, it will be given to 1 reducer 1, and then 4 modulus division 2, and the remainder will be 0, it will be given to reducer 0. So what we will be getting, reducer 0, that is the first reducer, reducer id 0, that is first reducer, reducer 1, that is the second reducer. In this particular way we will be able to see like the data movement uh, and reducer 0 and reducer 1. So you can define the logic in this particular way, or system is going to decide like it is going to move which key to which reducer. But the main important thing that you need to keep in your mind, only single key, say if big is given to this reducer, then big will not be given to this reducer. The reducers will have unique keys. Okay, there is one thing that will be there always. Reducer will be working onto the unique keys. If like we are having duplication of keys, say big is all available over here, big is available over here, then there will be issue inside the final output. So partitioner is a person who is going to decide there will not be the duplicacy of keys among the reducer. The reducer will be working on unique keys. If say big is given to this, it will not be given to this, so that we will be having the final output. Okay, although this is not true, this is not the case because mapper will have different keys, and say big is available over here, big can be available over here. But in order to give you like how the system is working, I have shown you the example. Say the system can have its own logic. Based upon their logic, it is going to decide the data is moving to which reducer. Fine so far, friends? Any doubt, any confusion? Huh?
No,
Anything
no,
that you are not able to understand? Huh?
no doubts yet.
Anyone? All of you?
No, Ashok, it's fine.
Yeah, fine till now.
Perfect. Huh? So what we have seen, partitioner is a person who is going to decide which key is moving to which reducer. Okay, so that like there will not be any duplicacy and reducer will be working onto the unique key, and we will be having the correct output. Huh? Now, now another thing that we are having, partitioner. Let me mention partitioner over here. Partition. Partitioner is working. That is perfectly fine. Now, what we are thinking, combiner. Another component what we are going to discuss, that is nothing but combiner. Okay, so combiner. What I have mentioned that like we just need to provide less amount of data to reducer so that uh, the maximum stuff can be done by mappers only, and mappers are going to work on to like the data, and that will be aligned in such a way that least amount of data will be pushed towards the reducer, and it will be working on less amount of data because this is the poor person and having no benefit of parallelism. And over here we will be having the benefit of parallelism. Thousands of machines uh, are are clubbed together over here in order to work on to a particular data. Now in order to reduce the load of reducer, what we are having combiner. So what we used to have, we are having combiners which are available over here. Combiner. Okay, so combiners are available over here. What I can mention, let me mention over here. These are available inside the mapper machine only. Combiner. So combiners are available on mapper machines only, named as mini mapper. Mini mapper, also known as mini mapper. So what we are going to do, we are going to add combiners in the data pipeline, in the Hadoop execution pipeline, so that it will be going to reduce the load of reducer, and like we will be having low latency. Let me mention over here, these are aligned in such a way that it will be reduce the load of reducer, and the job will be executed with low latency. Okay, less data movement towards reducer. Okay, agenda for this. So Minimapper or combiner, what we are able to see in this particular data pipeline, we have added combiner which are working on top of the mappers, and these are working onto the same logic which is given to the reducer. Say if we are performing certain operations by reducer, then we will try to do try to perform that particular operation over here only, so that we will be having the benefit of parallelism over here, and less data will be moved to the reducer. Now this is the agenda. This is the agenda, so that like the reducer will be aligned in such a way that the job execution can will be done with low latency. So combiners are working inside the mapper machines only, and they are working these are working onto the same logic which is given, which is written inside the reducer. So from the developer's perspective, we need to write down the logic for mapper, we need to write down the logic for reducer, we need to write down the logic for partitioner, we need to write down the logic for combiners as well. Okay, in order to perform a particular task, we just need to write down these particular logic, so that we will be able to do the execution of a particular task with low latency. Okay, now we will see these particular things with practical as well. So in practical, what we will see, we will be having a file, then it will be given to splitter, and then record reader, then mapper, and then reducer. So first, uh, the the first practical, what it will be based upon this particular pipeline. And then what we will do, we will try to set the reducer equal to 0. Reducer equal to 0. So can we set reducer equal to 0? What will be the benefit of setting reducer equal to 0? What will be the benefit of setting reducer equal to 0?
Latency will be low.
Definitely, from the developer's perspective, we need to think in this particular way, that no reducer job will be there. If no reducer job will be there, no shuffling, no sorting will be happening, and we will be getting the output from the mappers only. We will
With
be
the help
getting
of
the
combiner.
no.
Combiner.
Combiner is going to perform. Uh, Combiner is going to perform which task of reducer task? It is going to have the logic of reducer.
But
It is going to have the, and
uh,
combiner is just like a logical thing. That is not. It is available on machine. It is a program, you can think in this particular way. Okay, these are
but
the
from a
programs
mapper
basically.
we will get multiple outputs, na? Not a single output.
Ah, but combiner is working on each and every machine. And if we are able to, will we be able to accommodate the output from multiple machine? You need to think in that way.
Then without reducer, how we will get a single output?
Yes. So there are certain tasks, okay, where what I can say, there is no need of reducer. There are certain tasks there is no need of reducer. You need to tell me what are those tasks. Tell me the task which where we there is no need of reducer. Tell me certain task. Hmm. Any task? Okay, let me give you the information. So say where I can have where we are not having the need of reducer. Say I'm having say user 1, user 2, user 3, okay, oh, sorry, 3, 4, 5, 6. This is a table basically. 300, 400, 300, 200, 500. Mapper 1, mapper 2, and mapper 3. So this is the data what we are having that is given to the mapper 1, mapper 2, mapper 3, and I just want to the agenda what it will be like calculate the users who have spent greater than say 300. This is the agenda. I just want to find out the persons who have spent greater than 300. So from mapper 1, say I'm just adding the filtering condition. So mapper has given say user 2. Okay, in the same fashion like it will be having say user say no user 300, 200, and over here what will be having user 6. Okay, this is the outcome. This is the input to mapper and this is the output to the mapper. Do I need reducer over here? Do I need to club these records? Say yes or no.
Yes.
Do you need reducer over here? You are having the output over here only. User 2 and user 6. Why you are moving with reducer? This is reducer less job. Pankaj.
Still.
Huh?
I
We just need to.
think, yeah, if we want the total, that how much spent for these two users, then I think we need a
Yes,
reducer.
that depends upon the job. That depends upon
Mm.
application. I am saying like there might be certain applications where we can perform all the tasks towards the mapper side only. If we are thinking, say, we just need to perform the word count program, then definitely we need to have reducers. Okay, it might be possible that user 2 is available over here as well. Okay, at this mapper. So it is providing user 2 and user 4. What we want, like calculate the users who spend or find the users. Find the users. So find the users. find the users. So we can get the output from mappers, and that is perfectly fine. Like it has checked like user, say, is this amount greater than 300 or not? So if yes, then it is going to pick those particular users and provide you the list. That is perfectly fine. But if you want the total amount spent by say user, okay, then what you need to do, you need to add this amount. You need to add this amount. So user 2 has spent say 300, user say 400 over here, user 2 spent 400 over here as well, and user 6 has spent say 500. So you just need to give it to the reducer, and then reducer will work on 400, 400, 500. So it is going to provide me the outcome, say 1300. Okay, so at that moment I need to have a reducer. So depends upon application to application, and the stuff that we need to calculate. So based upon that, I can have a reducer and I can't have a reducer. Okay, depends upon the stuff that you need to perform, depends upon the application that you need to perform or execute, right?
Yes, Ashok.
Perfect. So that is the stuff like what we will be going to have with practical. Like if we need to set reducer equal to 0, then how we will be able to set reducer equal to 0. Then we will be going to see like can we have reducer more than 0, so that we will be going to see. Then the fourth step, what we will be going to have, if we are having reducer like more than one, then the partitioner will be coming into the picture. Partitioner. Okay, so we will be going through with partitioner as well. And if partitioners are there, then we will be having say, can we take the benefit of combiner? So we will be going to learn about combiners as well with practical. So these particular things we will be going to perform with practical, and we will be going to write down the logic with logic for mapper, combiner, partitioner, and reducer. Okay, so that these particular 5 steps we will be going to perform with practical, and tomorrow we will discuss on to that particular stuff. So that's it for this particular session, friend. And today what we have seen, we have gone through with the the job execution flow, how a job is being executed, or how a task is being performed with the help of MapReducer. And we have gone through with MapReduce methodology. And if I'm going to conclude what we have seen, the reducer, that is the poor person in the cluster, it is not having the benefit of parallelism, and mappers are having the benefit of parallelism, and we need to try to perform maximum stuff over here. But if we are not able to perform maximum stuff over here, we need to have reducer, then we need to take the benefit of combiner as well. We that is going to to reduce the load of reducer, because we are going to mention the same logic over here. So if you are going to see, it is going to take the input in key and value pair, output key and value pair. Combiner is going to take input in key and value pair, provide output in key and value pair. Partitioner is going to take input in key and value pair, provide output to in key and value pair, and finally reducer is also providing the output in key and value pair. So that is the stuff. Now once we will be going to add combiner in our job. So mapper input is given to combiner, and combiner output like that will be given to the reducer. So we need to I will guide you with respect to the data type and all, how we will be going to define. So in order to define input and output, we just need to think about the data type and all, and practically we will see these particular things. And the practical that we are going to perform, that will be done in Eclipse. Okay, so on the Cloudera Quick Start VM, Eclipse ID is there. Once you are going to open this particular ID, this is the Java ID basically, Eclipse Luna, and you can write down the code over here. And with the help of this Eclipse ID, we will be going to generate certain jar files, and those particular jar files we will try to run over here. That we will see through practical, friends. No need to worry on to that aspect. So tomorrow we will go in detail with respect to the practical. That's it. Let me stop recording and take your queries.